While Donald Trump secured the United States presidential nomination under the banner of climate change denial rhetoric, our planet kept spinning on its axis, and the human-caused atmospheric radiational imbalance added more heat into the atmosphere-ocean system. The World Meteorological Organization has issued a report that states 2016 is set to be the warmest year globally on record. The situation in the Arctic Ocean right now is completely unprecedented, with record low sea ice extent for the time of year and record high temperatures. So let's take a look at this crazy situation in more detail. So why does it look like 2016 will be the warmest year on record, even though the year is not over yet? This graph shows how the globally average near-surface temperature has changed from 1880 to 2016, with the years labeled along the bottom and the global temperature change on the y-axis. First of all, the globally average temperatures for the period January to September 2016 were about 1.2 degrees Celsius above those of the pre-industrial period. Now, the previous record for hottest year was not that long ago, as you probably already know. Yes, it was last year, 2015, and during that year the temperature was about 1 degree Celsius above the pre-industrial period. Given the continued global warmth through October, the WMO has concluded that it is unlikely that this year will be cooler than last year, and so will very likely be the hottest on record. This plot made by NOAA shows the regions where it was cooler or warmer than usual during October of this year. On the extreme ends of the color scale, you'll see record coldest and record warmest. Now, back on the map, if you look for any record coldest areas, you won't find any. However, look for record warmest and you'll find areas on most of the continents and over substantial areas of ocean, such as the western tropical Pacific and the Caribbean. This is the general pattern of the times we live in, where far more records are set for hottest temperatures than coldest. NOAA has an online tool that allows you to plot the global temperatures since 1880 for each month. The link is in the video description below. This is the plot for all the Octobers in the record. It shows that October was not the warmest on record. It actually tied with 2003 as the third warmest October on record. So it was definitely very warm. But what about the earlier months of this year? Where did they rank in the historical record? Well, let's take a look. This shows the record for all of the Januaries in the record. January of 2016 was in the far right bar, which shows up that it was the warmest on record. What about February? Well, it was also the warmest on record. Moving on to March, it was the warmest on record too. April, warmest on record. May, warmest on record. June, warmest on record. July, warmest on record. August, warmest on record. September, finally a month arrived that was not the warmest. Now, September 2016 was only fractionally cooler than the previous hottest September, and that was the previous year in September 2015. And there's an amazing fact hidden here, which is that before September 2016, there were actually 16 months in succession that were the warmest on record globally. So this September ended an incredibly long streak of record warmest months. And of course, that leads us back to October. So of the 10 months of the year, so far, 8 were the warmest on record. Now, these early month of the year records were due to the 2015-2016 strong El Nino. But why? Well, during an El Nino, the surface of the tropical Pacific Ocean warms on average, and this releases enormous amounts of heat from the ocean into the atmosphere. That then spreads around the globe in the atmospheric circulation. Can one ocean really change the global temperature? Well, consider the scale of the tropical Pacific Ocean. Our maps don't tend to give it justice due to the tendency to squeeze the projection near the equator. But from space, the Pacific Ocean is so large that it can almost make our planet look like it's an ocean planet when viewed from a particular angle. Such a huge mass of water means changes in the Pacific have profound influences on the global environment and are also implicated in the so-called pause in global temperature rise over the last decade or so. During that period, from about 1999 to 2014, there were no major El Nino events, which meant that there weren't any huge releases of heat from the Pacific Ocean, and this appears to have held off warming below the rate predicted by climate models. So we now know that the swish-swashing of enormous amounts of warm water in the Pacific Ocean is one key factor in causing the year-to-year fluctuations in global temperatures, while the trend related to climate change is best viewed over the timescales of decades or longer. Over the 2015 to 16 El Nino, it looks to have shifted global temperatures sharply upwards, which will nudge the trend to be closer to those predicted by climate change models. What happens next? We will have to wait to find out. Another thing that rose during the El Nino was the sea level. This plot shows the sea level change in millimeter as derived from satellites. It looks like it was a period where the levels jumped upwards. In fact, between November 2014 and February 2016, the average sea level rose 15 millimeters according to the WMO, well above the yearly average rise after 1993, which has been more like 3 to 3.5 millimeters per year. Thankfully, since February of this year, the sea levels have stabilized as the El Nino declined, but it's settled at a new high. Now, if you carefully look at the graph, you can see another notable jump in sea level. That one occurred during 1997-98, during the last major El Nino. The global sea ice situation right now can only be described as unprecedented and very concerning. The Arctic sea ice extent has been at an all-time record low for the day of the year since 20th of October 2016. To be clear, as an example for 20th October, this means that over the observational record, there has never been this low of a sea ice extent for any 20th of October in previous years, or for any day since then, up to the time of this recording on the 21st of November 2016. October sea ice extent was 400,000 square kilometers less than in 2007, which was the previous lowest on record. The situation has gotten even more extreme recently, with the mid-November sea ice extent some 580,000 square kilometers less than the next lowest year. I believe this deficit has grown even larger now. How large is 580,000 square kilometers? Well, put it this way, more than twice the area of the United Kingdom has been knocked off the record. Just one storm on 17th of November looks to have reduced the sea ice extent by 50,000 square kilometers, at a time when the sea ice should be growing. Another exceptional fact is that the Antarctic sea ice extent is now also at record low levels for this time of year. Up to this year, the Antarctic sea ice has not declined like the Arctic, and in fact showed some growth over the last decade. Since both the Arctic and Antarctic have record low sea ice extents right now, what about the total global sea ice extent? Well, of course, it's much lower than it has ever been in the record, by an enormous margin, as shown in this plot made by Witness using data from the National Snow and Ice Data Center. What is that margin? Well, by mid-November, the total global sea ice extent was 4.2 million square kilometers below the average, and well below anything we've ever seen for this time of year. What about the actual temperatures in the Northern Arctic? How have they been faring recently? Well, a good way to look at this would be to take a circle centered on the North Pole and calculate the average temperature, so that we can see how the overall Arctic temperature is changing. Good news, the folks at the Danish Meteorological Institute do exactly this. For the hashed area on the map, which marks all the area of Earth north of 80 degrees latitude, they calculate the average near surface temperature. The day of the year is on the x-axis and the temperature is on the y-axis. I've labeled the seasons for reference. The green line marks the 1958 to 2015 average temperature curve for this area. The red line is the 2016 average temperature calculated for the same area for 2016 so far. You can see that the red line is far above the green line at the moment, the right end on the red curve. It's an indication that the Arctic is cooling down far less rapidly than usual as we head into winter. In fact, it's unprecedented. Of all the years at the Danish Meteorological Institute's websites, and even the very warm years like 2015 and 2007, they were all cooling off by now. If you want to take a look at other years, the website is in the video description. This extreme Arctic warmth has developed because of a huge influx of warm air from more southern latitudes. The warm air appears to have at least partially originated all the way back in the tropical eastern Pacific, and was recently drawn in by large storms. But while the Arctic has been warmer recently, northern Asia has been much colder, and they must be scratching their heads over all this talk about exceptional warmth. It's as though a huge displacement of cold air has occurred. The unusually warm Arctic and unusually cold northern Asia are directly related to unusual jet stream behavior that has forced low-level storms in high-pressure regions to redistribute masses of air. There have been record snowfalls in Stockholm, and check out this picture from Yakutia, northeast Russia. The cold Asian weather and the extensive early season Asian snow cover may have influences on how the winter plays out there and downstream over North America. We wait and see what happens next in these strange times for our atmosphere. So overall, 2016 is turning into a truly exceptional year. It will very likely be the warmest year on record globally. The reason for the record is partially due to a Pacific Ocean release of heat stored over years due to climate change. There are never before seen late-year warm temperatures in the Arctic, and the lowest sea ice extent ever for this time of year in both the Arctic and the Antarctic. If you'd like us to produce more videos like this, please subscribe to this channel, and thanks for watching.